Section 3.5, Parallel Lines and Triangles. We start off this section with a postulate. This is not an important postulate. In fact, its only real use is that it is used to prove the first theorem of this section. You won't actually be using it in any of the proofs that you do. But it does show up in this section, so just to be thorough, here is this postulate very quickly. It says that through a point not on a line, so a situation like this, here I have point P, which is not on that line. This postulate says that through this point, there is one and only one line that you can draw that is parallel to that original line. And that's it. Pretty simple. Pretty obvious, like most postulates. And like most postulates, it gets that same, well, duh, response. And like I said, it is only used to prove the next theorem, which is incredibly important. This postulate, not so much. Before I get to the next theorem, there is a demonstration that is interesting involving triangles, which illustrates the next theorem in action. With this demonstration, you are certainly free to follow along if you'd like. If you'd like to participate yourself, go ahead and get some paper and cut out any type of triangle that you like of any size. It can be a right, acute, obtuse, whatever strikes your fancy. This demonstration will work for any of them. You will want to make sure that your cuts are as straight as possible, though, to have this come out as best as it can. Once you have taken the time to cut out a lovely straight triangle, then we get to mutilate it. Doesn't that sound fun? Take your triangle and rip off the angles. Don't cut off the angles, we want to rip off the angles. Ow! We want to leave this jagged piece here. The jagged piece will help us when we do the next step. Do that for all of its limbs. We're going to leave this sucker limbless. And rip off the third angle. Once you've ripped off the third angles, you should have something like this. We left them ripped on one side so that it's obvious which side is the rip side and which side was the angles of our triangle. Now what you're going to do is you're going to take the angles of your triangle and put them together so that the points all touch. And if you do that, you will notice that the three angles form exactly 180 degrees, a straight line. This works for any type triangle, so if you chose a right, obtuse, acute, it doesn't matter. This is actually a physical proof for the next theorem that we're going to cover. This brings us to the triangle angle sum theorem, which is what that last demonstration was showing. This theorem says that for any triangle, big or small, right, acute, or obtuse, scalene, isosceles, or equilateral, for any triangle, the angles will always add up to 180 degrees. That postulate from before helps prove this theorem. That postulate isn't very helpful, but I can't underscore enough how useful and how often you will be using this theorem in math, especially in geometry. It comes up all the time, sometimes in proofs, but more often just in problems. You will often just have two angles of a triangle, and it is assumed that the first thing you will do is quickly figure out and calculate what the third angle must be and move on. Sometimes you will need to do it a few times in the same problem, but it can't impress upon you enough just how common that task will be this year. It happens all the time. The next thing we will look at will be the exterior angles of a polygon. I have drawn a triangle on this page, but this discussion works equally well for any polygon. I am just using a triangle here since it is the most basic polygon, and I wouldn't have to draw as much. Yes, even I can be lazy sometimes. In any case, we want to look at the exterior angles of a polygon. We have been dealing with the interior angles up till now. It is the interior angles of a triangle that add up to 180 degrees. So interior angles are on the inside of a polygon. Exterior sounds like it should be simple. Those would simply be on the outside, right? Clearly it must be these, right? Sadly, that's not correct. In this class, except for one exception when we deal with arc lengths and sector areas, we don't deal with angles over 180 degrees. And that holds true here. These are not the exterior angles. The exterior angles are actually the linear pair of the interior angles. So to find the exterior angle of a polygon, you need to extend out a side like this. With that side extended out, the exterior angle that is the linear pair with the interior angle is drawn in. You can similarly do this with the other angles of the triangle. So these are perfectly valid exterior angles. However, they were not the only way that I could draw these exterior angles. I just picked out a side to extend at random. But just to show you, I could have just as easily extended out the other side as well. This also creates valid exterior angles. So the choice is up to you. Extend out one of the sides. You don't need to extend out both. One will suffice. And that will draw in your exterior angle. Your interior and exterior angles are a linear pair. Now we want to go over the idea of remote interior angles. Remote interior angles work together with an exterior angle. So I have drawn in one exterior angle angle 1, in the picture. So let's think about the meaning of the words remote interior. First, I will deal with interior. There are 3 interior angles of the triangle. So we are only thinking about those angles. Now let's consider the word remote. What does the word remote mean to you? If you are on a remote island, that is an island far away from everything. Undoubtedly, that sounds nice to some of you. For others, it would drive you crazy. If you have a remote control, you are controlling your television from afar. It would defeat the purpose of the remote control if you had to be next to the television to use it. You could actually push the buttons on the television itself. Then, people used to have to do. Yes, really. They actually had to get up to push a button on the television to change the channels at one time. Unthinkable. How did people survive? But remote means far away. So back to our interior angles. We want interior angles that are remote from our exterior angle there. There are 3 interior angles. One of them is right next to the exterior angle, so that one isn't remote at all. However, the other 2 angles are remote from our exterior angles. So it is these 2 angles which are the remote interior angles for our exterior angle. Why go over that vocabulary? It's for this theorem, the triangle exterior angle theorem. It says that any exterior angle of a triangle is equal to the sum of the remote interior angles. For the picture below, that means that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. That's it. That theorem helps out in situations like this. If you were presented this problem and you didn't have that theorem, you would have to go about it like this. First, you would need to set this angle as some other variable. Here I will go with y. Then you would know that the interior angles of a triangle add up to 180, so you would have this equation. Then you would know that you have a linear pair, so you could set up this equation too. And then you have 2 equations and 2 unknowns. It's your favorite thing from algebra, a system of equations. Then you would need to substitute or use elimination to find the value of x. However, we don't have to do that anymore. With the triangle exterior angle theorem, we can get rid of that system of equations. And we can get rid of that extra variable. And we can go directly to a simpler equation. We know from the theorem that the exterior angle, in this case the angle measuring 12x minus 5, is equal to the sum of the remote interior angles. That equation is much nicer. No system of equations, no second variable. This should be a trivial problem to solve. And that is how this last theorem will help save you some work. You can certainly still do the problem without it, if you want to deal with a system of equations, but it saves you some time. It isn't as prevalent as the triangle angle sum theorem, although few things are as prevalent as that one, but the triangle exterior angle theorem will be helpful a few times this year.